Welcome and introduce Riccardo Williams from Directorate General European Commission, who will talk about the regulatory framework of smart grid PCIs. Riccardo, please.
Thank you, Beatrice.
Thank you.
Good morning, everybody. And thank you, Uros, for organizing this. I'm very excited to be here. It's my first summit, real summit in quite a while, after a lot of virtual ones. So this is nice to see so many faces interested in this very good summit today. The reason why we are so excited of this specific summit is because it's the first of its kind. We put together a lot of very good projects of common interest, and we are going to learn a lot today. So I personally and DG Ener is very excited about this. You are very well aware of the current energy situation, and Uros made a nice hint on the rain. I fully agree, we should all dance when it rains. The situation is quite complicated. You know very well what's going on with Russia, with Ukraine. The energy prices are just skyrocketing. We have a very high inflation. This is a difficult situation. And we should not forget what is the long-term battle, which is climate change. And all of this comes together, and it's projects like these ones help in this. In the short term, you may have seen what the Commission is doing. We have made a number of proposals of what we need to do in the very short term, how to solve the situation or how to mitigate the risks. We need to diversify our gas supplies. We need to, each of us, do individual actions to save energy. We need to consume less. We need to be more responsible than ever, not only because we will pay less, but also because we need it, not to have a blackout or not to have risk of blackouts. And we need to keep increasing our gas storage and do other complementary actions. This is in the short term. The long term, nevertheless, has not changed. In the long term, we need to accelerate the energy transition, and that means that we need much more renewables. We need to put them on the ground and on sea much faster than we are currently doing. And for doing that, we need to do certain things. We need to accelerate permitting, and that's why we have made in the Renewables Energy Directive proposal, which regulates how renewables are to be deployed in Europe. We made certain proposals under the Repower EU, so the package that we did as actions after Russia, to accelerate permitting for renewables. And we need, when we are talking about putting more renewables, it means that we need more grids. Otherwise, it doesn't make sense. We need to be able to integrate it in the system. And this is where projects like the ones we're going to see today make a lot of sense. In the revised TENI regulation, the Trans-European Networks for Energy, that was adopted very recently on the 23rd of June, we have adapted the existing regulation that we had already for the last decade and a half to make it compatible with the Green Deal, with the sustainability, with climate change. And in this, we have improved the provisions on the kind of projects we want to see in Europe, of cross-border projects, and we have new elements, offshore renewables, we have and grids, we have CO2, we have hydrogen, so an expansion of what we had and a development of new things. And we also have made certain improvements related to smart electricity grids. And that means that we listen to what project promoters were telling us in the past before the revision, and we facilitated, we streamlined certain procedures so that it's easier for you to propose new projects. With this, I will close. Just the last thing. Smart grids enables a lot of new ideas, a lot of new businesses. It's all about having more renewables, but also more distributed energy, more aggregators, more collaborative approaches. And this is something that is enabled also with digitalization. And that's very soon we will be publishing a digitalization of energy action plan, which will also for distribution and transmission, energy and the energy sector as a whole will be helping further on having this kind of new businesses around Europe. So that's a little bit the reason why we are so excited about this. These projects enable achieving these policy objectives, and I look forward to the discussion now.
And now I kindly ask Mr. Uroš Kerin from ELES to open panel 1.
Thank you very much to all of you for joining us here today. It's a very pleasant day outside. Even if it will rain, it will just bring additional dynamics into our lives, which is also good. Also, our grids are becoming very dynamic, and we are all keen on that, especially engineers, because it gives us a lot of work and challenges. Today, we will have a rare opportunity to hear about actual smart grid projects. In the Power Engineering Society, there are a lot of discussions on a theoretical level, but very few of them really are being realized and translated into practice. But not in our case. In our case, we will be able to see the actual application, the actual outcome of some of the, well, let's call them very, very state-of-the-art projects. You see the list here. The first one is, okay, sorry. Let's just click this here. Okay, the first one would be our local one, SINCRO.GRID project. It will be presented by my colleague Simon Todt. And then we continue with the projects ACON, DANUBE INGRID, and GABRETA. But you will see during the presentations, it's not only about the projects. The projects and the grid, they are not the ones that are smart. People are smart. So basically, these projects, what they do is not they just bring technology on the same level, or they allow human societies to benefit from the technology. It's much more. They allow nations to come together. They help us remove language obstacles. And at the end of the day, they make Europe great. I know you heard that somewhere, to make Europe great. So I'm saying this quite intentionally. But it's not about me. So I'm Uroš Kerin. I will be just sharing this session. It's about the presenters and their projects. So I would say, without further ado, to invite our first speaker, which would be Simon Todt, to come here and explain us what his project or his projects are all about. Thank you.
So, good morning. Thank you very much. Today I would like to present our first smart grid project, SINCRO.GRID, and after that a few information about the next one. This is GREENSWITCH project. But I will start with the first one. This is the first completed project of PCI list, and in the priority or thematic of area smart grid deployment. It's very important for us and for our partners. And in this project are involved 2 countries, Slovenia and Croatia, and 4 companies are involved in this project. 2 transmission system operator and 2 distribution system operator. What was the beginning of the project, or challenging, the main needs? We started with solving the voltage profile. We noticed that we have some difficulties and issues with the voltage, high voltage, and this was the first step to approach this project. Of course, then we make some analysis and started with the research, and we would like to improve the balancing performance, utilization of the grid, higher potential of renewable energy sources. It's very important. Observability of the grid, and of course, we would like to put everything in the cost-effective level. So, coordinated investment action should be in the way, on optimal way, in technical and of course economical part, and we take in account that we need some impact on the whole region. So this is a short overview of what everything done in this project. So we would like to increase the flexibility of reactive power. This is our first and the main goal. And we started with the next one. This is the flexibility of active power, because the flexibility is very needed in this situation, and will be needed even more in the future during the transition of the system operator, of the grid. Increasing transmission line capacity without construction any new power lines, it was challenge, and I think we managed with the system dynamic thermal rating to increase a little bit power flow, because with the numbers what we have now, it's possible to increase between 15 and 20% in the some areas. And the last functionality was the so-called virtual cross-border control center, and we managed to gather all these components and put some smart components on the conventional equipment. So if we are talking before about conventional equipment, now we was putting some smart grid component in this area. So I just want to point out the main reason what happened on the grid in 2014, for example. In this case, this is the real data, and unfortunately we have had this time, for example, in some nodes, essential over voltage in the grid. For example, over 8,000 hours per year, what is unacceptable. So we have to do something about this. And this was the main trigger when we started with the project. So the answer for all this challenge was the implementing of the compensation device. We started with the analysis, with the studies, and of course, during the communication with our partners, we managed to decrease at least one compensation device in each power grid. What is quite big step forward about optimization. So the first, I wanted just to go through these devices. So the first one is variable shunt reactors in Divača, and in this substation we implement also mechanical switch capacitor. Further on, we go on with the variable shunt reactor in Circuce. This was the second part of SINCRO.GRID project, so phase 2, but it's already finished and it is in operation. The last device in Slovenian part is STATCOM, static synchronous compensator, the state of the art of the devices in this field, and it is deployment in this area, and we can see after the session we can visit this device, but unfortunately we cannot enter in this place on the picture because the device is in operation and it's work. Then I go to the Croatia side. We implement variable shunt reactor in Melina, and after that we the same variable shunt reactor in Mrcelin. And we close with the implementing this device in Konjsko near Split, where we implement static synchronous compensator SVC, and on end of the day, all the devices are in operation and work even better when we expect. So this is the real time. This is the picture from our SCADA, and it's shown the situation when we don't use the compensation device. The red color is sign that the grid is over voltage. So the deeper, the more red color means higher voltage in the grid, and because I just want to point out this is the real situation, and when we use the composition device, we get this kind of picture where the voltage with the over voltage situation is practical. We don't have any issue with this system. I just want to find and show you some pictures after switching the device, composition device. This is the part of Divača, and you can see we have 7% of the time when the voltage was too high, but after the switching on the composition device, this situation go below 1%. This is the main point of this composition device is, of course, maintains accepting voltage. This is the first and the main issue. But anyway, we improved the network stability with these devices, and actually, as you see in the previous picture, we put some positive impact to the neighbor country, what is also one of the goals. For the activity, for the active power, increase the active power, we implement 2 battery storage. Of course, these battery storage are contributing the green transformation, and we use it quite a lot. And also with these tools, we actually gain some tools for safety mechanism regarding the frequency control. The first battery storage was implemented in substation in Okroglo, here near Maribor, and the second one in Kranj, Pekre, sorry, this is the Maribor, Pekre, and the previous one in the Okroglo, Kranj. We have, together we have 10 megawatts and 50 megawatts hour, what is quite enough for this stage, and we are very satisfied with this situation. The next one is so-called dynamic thermal rating system. This allows us real-time monitoring on the local condition on the overhead power lines. Very important because we would like to monitor and control the whole grid. And so, of course, we improve the safety, but more than less, we manage concern the weather situation, increase the power flow without building the new power lines, and of course this allows us to actually to move the energy from the renewable energy sources on the coast with the wind power plants to the regional market and to the west of Europe. I would like to point out in this slide also weather station. This is somehow of our knowledge, and actually it was built by ALS with the partners, and we can manage to observe and to get the real-time data for the weather, wind, humidity, everything what we need to calculate the possibility to increase the power flow to some power lines. The last, but not least, of course, is virtual cross-border control center. This is the heart or eyes of everything devices. And I think this is the first case when we, through with voltage wall control and voltage wall shadower within this virtual cross-border control center, we managed to control and to put the regulation in this system. So with this, for the next step, I think everything what I mentioned is grid controllability. This is the part of this active power, so flexibility, increase of flexibility, and everything. And this should be done in the future. So I think you should look for more and more this project because otherwise we cannot succeed with this green transformation. But the challenge is how to this point to this project put in international structure project with together with the design and implement like in Europe. This is all for SINCRO.GRID, but I have another one. I have to close it. Yeah. So the second one, this is the new. It was. It is in the fifth PCI list, GREENSWITCH. It's almost this. It's not the same, but we go on with solving the issue on the grid. So, but this is the bigger consortium. We have three states: Austria, Slovenia, and Croatia, and 9 partners are involved in this project. So we are talking about distribution company from Austria, 3 distribution companies in Slovenia, and distribution system operator from Croatia. Then we have 2 transmission system operator in Slovenia and Croatia, and we have actually the producer of the electro energy. This is GNI and HIP did. This is the area where we have where we will have some influence. So in Austria, Slovenia, and Croatia, the goals. I think it's quite important. We would like to enable the integration of increasing the quantity of dispersed and renewable resources, and of course the new loads, because we should be aware that more loads will be connected to the grids, like heating pump, cars, and so on. And the second goal is we would like to improve observability of the distribution network. The third one is improve the power supply quality. This is very important during the transmission to the green transmission. And we would like to use the infrastructure, what is also so important because we would like to achieve some cost-effective approach. The last is, which I mentioned here, it's enable prosumer to get some kind in the front line of the power system. So we are talking about the smart to enable the smart homes, the smart villages, and so on. The pact, what we expect 10 gigawatts heating energy from extraction of heat from transformer. We would like to increase the hosting capacity of the existing network, so without new investment, better utilization of existing transformers for in the middle and low voltage level. We would like to pick 10% lower peak demands with using flexibility sources. And of course, this is the new one. We would like to establish the green connection for heavy duty and fast charging station. We would like to implement the follow technology, HDTLS. This is the one to increase the power flow through the power lines. We would like to finish actually the dynamic thermal rating system with the all cross-border power lines, and of course we implement these devices to the transformer. Extraction of the heat of the transformer is some kind of the cooperation with the heating sector. Like is connecting the heavy duty and fast charging station connected or together with the e-mobility. ICT network should be done because we would like to connect everything. Then the distribution company have automated primary and secondary substation. And this one is power flow control. It's quite important because this is if we have in SINCRO.GRID the flexibility of active power and reactive power, now we would like to control and regulate it, the power flow control, because this wasn't in the previously project. Shunt reactors, advanced distribution management system are included, and of course the battery energy storage system for a lot of purpose, for example also with the virtual power plant. So this is just a scheme of the project. Everything is connected, and I think the project is quite demanding, complex, and with a lot of partners. But we have some coordination meetings and everything. It's quite nice. With this, I would like to close my presentation. Thank you very much.
So I invite our next speaker, Tomasz. Please come to the stage and tell us everything interesting about your project. Thank you very much.
Thank you very much. Thank you very much. I have to start with a personal statement because for me entering this room was like entering a reunion with old friends, meeting Simon and Mate. I remember the first time we met in 2017 when we started the whole PCI journey, and that time SINCRO.GRID was exactly the first project that was successfully already part of a co-financed action. And I have to say the truth that it was also a circumstance that motivated our activity to join the PCI arena. So I would like to thank once again for you guys especially, because we had a lot of discussions in Brussels at the time that we can be also currently here with our projects. When it comes to the project ACON is the kind of the first PCI project in our country, in Slovakia. And the project itself also has a name. ACON, it's not a name really from the energy business, it's a name more connected to the history. It stands for, again, connected networks. Because as you all know, Slovakia and Czech Republic were previously one country that were separated by 1993. And our project is practically building on a common history of these two countries. I have to say that all the issues, and I'm willing to tie up to the discussion or then to the notes that Simon was just providing, that we were in a lucky situation, again, building up our project, that we had no language difficulties. And I think when we are speaking in Europe, even between neighboring countries, speaking different languages, and to have a common language can be quite a huge benefit to set up a project and to develop the whole project idea. So as for our project ACON, we always like to say that we have also kind of a priority in some issues, and our primary role is that, according to my knowledge, it was the first pure DSO project in the PCI arena. So compared to the project SINCRO.GRID, where also the TSO is involved, in our case, the TSOs were acting only as a supportive members, both from the Slovak and from the Czech side. But as for the project itself, it was built purely on a DSO platform. So allow me to say that it was a kind of first DSO-based smart grid project that was developed. As for the project area, as you can see also on the small map, the project area is covering the southern part of the Czech Republic and the western part of the Slovak Republic. The whole project value is just to provide some numbers. I'm not willing to bore you with the numbers. The value of the project is 182 million euros. The portion of the countries is more or less the same, 50-50% between Czech Republic and Slovenia. And we started the realization of our project in 2018. It's the time when we started our relationship, and allowed me to say our friendship with Eduardo. We met we had the first meeting at the premises of INEA at that time. It was not SINE, it was INEA back in the history. And in 2018 we started the realization of the project, and according to our plans and projections, the project shall be finished by 2024. Project was, as I said, was enlisted. It was included also on the third list. It's included on the fourth list. Luckily, also on the fifth list of the project. And we received the co-financing rate from the European Union at the level of 50%. So altogether, up to 91 million euros of the eligible costs of the project. When it comes to the thematic background, what's included within the project? So our project is built on four main technological pillars. The first one is the cross-border interconnection improvement. Slovakia and Czech Republic, again, it could be a different thing compared to other countries in Europe. We have an existing cross-border DSO connection. It's not really a usual thing between the European countries, but due to the fact that we were one country before 1993, so it was the way how also the distribution grid was built up, and we have also existing cross-border DSO connections. This cross-border DSO connection is used only in some extraordinary circumstances, but the relevance of this cross-border interconnection at the DSO level was proved, unfortunately, last year very much when there was an issue with the tornado in Czech Republic. It was rather in this cross-border area, and the existing possibility of the power supply also using this DSO cross-border line helped and is still helping our Czech partners to provide power supplies to this region. Within the project ACON, we are strengthening this cross-border interconnections at the DSO level. We are pretty much aware that according to the current European legislation and the legal framework, we are not allowed to use these power connections for a regular power exchange currently. But we are still using these lines as a backup lines for this region. Unfortunately, this region of Moravia and of the western Slovakian part called Záhorie, it's not very difficult to pronounce. It's the issue of the security of the power supplies. It's very relevant. So we are using, in some cases, when there is a planned maintenance or when there is a mismanipulation within the grid, we are using this existing DSO power supplies, power lines to provide powers and to help each other between the countries. The second pillar, it's technologically and also economically more massive. It has a very fancy name, management of the distribution grid in new conditions. And what this exactly mean is that we are building up also new substations. Also within the project ACON, we are building two new greenfield substations, one in the Czech Republic, one in Slovakia. We had the opportunity also to welcome a site visit from the part of SINEA this year to monitor the current way of works. And according to the current projections, the first substation, it's really a massive investment up to 15 million euros. Shall be finished by the end of this year, so the final commissioning is expected to happen in the first half of 2023. Also within this activity, management of the distribution grid in the new condition, we are just developing some so-called smart substations, smart TS transformation stations within the project area, also within Czech Republic and within Slovakia. The approach is not the same, so the technical characteristics of these smart solutions are not the same on the two sides of the border. They are reacting on the national circumstances and of the needs of this region. The third pillar, it's a more an IT pillar, and it's about developing the IT and then the optical connection routes between the smart devices. Because our intention when we also started the discussions about smart grid, what is a smart grid, and when we started to explain it also to our politicians, to our regulator, there is a very narrow definition in the current 10E regulation what's a smart grid. But from our perspective and what we are willing to achieve within our smart grid is to really to turn the lines on within the DSO. It means to allow the DSO to see what is happening within the grid. For this purpose, we already have, and I'm sure that all of the DSO companies across Europe, they have smart devices that are monitoring the happening and the development of the grid. But within our third pillar, within the smart IT solution, we are willing to connect the existing IT elements within our grid by optical routes, so we can have a closed system of data exchange, also to promote cybersecurity. But we are not only collecting the data, but we are also analyzing the data. So there is a huge IT platform built on how to analyze the losses in the given nodes of the distribution grid, how to maybe forecast some failures in the grid, how to improve the whole management of the grid. And the last pillar, it's communication and dissemination. I have to say that it is one of the items of the project that was completely new for a DSO company. I'm not willing to say it generally for all the DSO companies, but I think that I can say it at least for our company and for the Czech colleagues as well, that DSOs were usually not used to promote what they are doing. We had the positions that to be like a secret service, nobody knows about what we are doing, and it's the best, but in this case we have to also to promote it. And it's definitely a new learning to be also visible on social networks, new activity to also organize conferences. And I have to say that it is also transforming the whole environment within the company. So now we are thinking also to improve more the visibility also in different projects. But the starting point was definitely the participation in the ACON PCI. Okay. I said the content of the PCI, but myself, I have to confess that I'm not a technician. So when I had the meeting with the technicians, it was also the discussions, what's the difference between a PCI project and a non-PCI project. From my perspective, they were just building some lines or some substations, but what's the difference? And then we learned, and I have to say that, again, back to the first meetings in 2017 with Mate and with Simon, when we asked, and they replied, you will learn, and we learned. There's a lot of difference, and the one thing is that really there is a cross-border cooperation between the TSOs and DSOs. So usually DSOs were not used to have a cross-border cooperation. Also, there were some former associations like the CER, CEAR, or the EDSO, a non-formal cooperation of the DSOs, or different platforms, but there was not something like ENSO-E or ENSO-G for electricity and gas TSO. Now the situation is different, but when we started in 2017, the story for the bit within the history. And to start the cooperation with the DSOs, it was, again, despite of the fact that we were speaking the same language, we had to adjust also all our actions and to plan to have common meetings. But it's definitely an added value, but a difference compared to a non-PCI project. But the biggest difference, and I'm willing to emphasize this, is the obligations that we are having from the grant agreement. Again, I'm not willing to speak generally on behalf of the all DSOs, but usually DSOs are not announcing to the regulator what are the milestones of the given investment. So we are announcing that we are planning to build a substation or some kilometers of lines, but without strict miles and then the road of development. It's a different story, and the officers from SINEA are quite keeping the eyes on the agenda and the time frame. But again, it's a big learning from the company. It's pushing us to complete our investments on time. It's a big learning then also obviously mirrored in the other PCI projects. And one of the last things that I would like to mention when we are speaking about the PCIs and the non-PCIs is also to have a third-party expertise. Especially for our projects, we are using a third-party expertise to have like a referee who is then deciding between different project ideas, or when we are completing some position documents. Because despite of the fact that we are all speaking also quite sufficient English, but there are also some different words, and Eduardo in this area is very keen on the correct wording, so we have to adjust all our documents. So I would like now to conclude with this point. So thank you very much once again. And I really also encourage, as Simon said, that to enter the PCI arena, to promote the project, it's not an easy journey, it's a difficult one. But from my perspective, it's definitely worth to go this path. Thank you very much.
Good morning, and I would like to thank our hosts. for inviting us, and also the European Commission and SINEA, because it's a very nice event. It's a very nice knowledge share, and I think that is one of the main findings of our project. So in the background, I will start a video because it's showing much better all the technical content, and I will talk in between. So actually, we started our project together with Slovakian colleagues, the Slovakian TSO and DSO Západoslovenska Distribučna, and E.ON Hungary, one of the distribution system operators of E.ON in northwestern Hungary. You will just see the map in a bit, and Mavir, the Hungarian TSO, is a supporting member in our project. We started our project actually planning the project in 2018, and you can see the project area. The northern part is western Slovakia and northwestern Hungary. The reason why we did this project was actually we had the impetus from the renewables. So we have really a lot of renewables who want to connect to our grid. So therefore, we have to make more capacity, free capacity on our grid, and we also need to manage them. So we need to build some new capacities like lines, but also smart substations. And now you will see a meteorological station, which was also mentioned in the SINCRO.GRID project. Actually, this is quite important that we have really extreme weather conditions, and we need to prepare our operators for that. In order to get more data on our grid and to have more, so we would like to get more data and information on our grid. So we apply smart devices, remote switches, ring main units, etc. And in order to gather all the information, we also build optical cables. But we do not want to just gather them, we analyze them and we use them for our investments and also for our operation. And we exchange softwares like the GIS system and the SCADA system. So this is the main content of our Smart Grid project. So on the one hand, we use so we increase the capacities. On the other hand, we use smart management systems. This way, we increase the reliability of our grid, and we also increase the capacity of the grid, and also ensure the security of supply. Actually, I think Tamás already mentioned, because he participates in both projects, so I think he mentioned the main characteristics of a PCI, so I would like to reflect on them. So first, we had to find really reliable partners in order to do this project. And fortunately, TSOs and DSOs are quite professional and reliable partners, and this is quite a good opportunity to learn from each other. So actually, I think that's all from our side.
Good morning, ladies and gentlemen, also from my side. My name is Fisnik Musai. Fisnik is my first name, Musai is my last name. We had written it in another direction. Since 2009 in Energy Business Active, I've worked in different positions within E.ON company. And now I am head of high voltage solutions at Bayernwerk and managing with two other colleagues this GABRETA Smart Grid project. The agenda is short. I will tell at the beginning why we are doing this project, then what we are doing, and yet what are the benefits of this project. So first, a general overview. You can see here who are the project promoters. It's our colleagues from EGD, and we, as Bayernwerk, we have our partners, our TSOs, respectively, TenneT and CHEPS. And you can see here on the left corner the location of our grids. The project will start next year and will be executed within then 8 years. So first the question, why we are doing that? There's lots of text here, but please focus on these two main messages. One is we want to address this transition towards a low carbon economy. This is the first one. What does it mean? I'll come back. And the other one is the securing safe and reliable supply of energy. So what does it mean, low carbon economy? We have to go back a little bit in time. In Germany in year 2000, there was for the first time, the Renewable Energy Act was introduced. This is Erneuerbare Energiegesetz. And the objective of that was to get rid of fossil fuels from the energy production. This laid the foundation for the expansion of renewable energies in Germany. For example, let's take solar photovoltaic production. In year 2000, there was 100 megawatts in Germany, and I checked yesterday, 58,000 megawatts. This is 58 gigawatts already installed in the grid. 1/3 of it is installed at Bayernwerk-Netz. And our forecasts say that it will double within the next 10 years. So to integrate these renewable energy sources to Bayernwerk grid, we had to invest a lot into our grids. At the beginning, we were profiting from existing capacities, but then later, it's getting even harder and harder. Now, we have to double down or triple our efforts in investing in our grids. And so is how we want to address these needs to make it possible that we go to this low carbon economy by enabling integration of renewable energy sources into our grids. What is our plan? Well, our plan is to continue investing on our infrastructure, but it's not just demolishing the existing one and building with a higher capacity, but doing it smartly. So we are planning to invest in our grids, continuing investing in our grids. The other one is we want to connect now our grids in the border region with the colleagues from Czech Republic, and so to increase the reliability of supply in that area. We want to exchange data with our both companies. This data will help us getting better in predictive maintenance and so on, and also increase the flexibility. So what are we going to do concretely? So the ones who work in grid companies already know, but the other ones less, that it used to be so that under the primary substation, I could say that the grid was smart. We could see everything, voltage, current, power flows, etc. But when we leave at the primary substation and go into the grid inside, so in the middle voltage and low voltage, it's like a black box. We could not see anything. But the renewable energy sources are connected to the low and middle voltage grids. So without seeing it, what's happening there, you cannot decide what to do rightly. So that's why our investment focus first to to observe the low and middle voltage grids. So the investments that we do there, it makes it possible. So we will see how is the voltage, how is the current, how is the load flow, and also to act. So when we see a problem or overload there in the low or middle voltage grid, so we are now able to act on that, to switch something, to tap the transformer so that the voltage levels are again in a correct level. We have 4 pillars in our project here, Smart Grid project. The first one is interconnection and strengthening of distribution grid. So it's that this is the part where we connect our grids with each other. We are planned in 3 regions to connect our DSO grids. And here we have also this one that I told at the beginning, planning to increase the capacity of some existing primary substations. So it's like we are planning at Bayernwerk site to build completely new primary substations and to expand 8 existing primary substations. And in the Czech side, I think they want to build new, extra 2 new primary substations. In the pillar number 2, modernization of distribution grids, this is the part where the music plays. So we are planning here to install many digital secondary substations, voltage regulated distribution transformers, many of them, and yes, also the universal monitors and reclosers and so on. The third pillar is the pillar where we have to get the data from this secondary substation, and we have to be able to send the information back to the secondary substation. So we have to build these connection rows, the information connection rows. So that's why we are here investing a lot in optical fiber networks. And last but not least is the smart grid IT solutions. So here we were investing in software so that many things could happen automatically, and also analyzing the data which are coming from the secondary substation and transformers. What is the benefit of this project? So the first one is environmental. I told at the beginning, we want to go to the low carbon economy. So the first benefit should be environmental. So the CO2 emissions should vanish. So that's the main objective. We have also economical benefits. So we decrease the losses in our grid. And also by doing these investments smartly, we are also saving money because we want to avoid just demolishing existing infrastructure and building with a higher capacity. But we want to use the existing capacity at maximum, so that the last step should be going out and demolishing and building a new one. And the last but not least, our customers. Well, the customers, for them, it's really important to have reliable energy supply. It used to be reliable in the past, and it should continue to be reliable in the future. We are dealing now with fluctuating energy production, but the customers at the end shouldn't feel something that has getting worse in the energy supply. It should stay the same. So that was my presentation. Thank you for your time.
Okay, so we all heard 4 presentations. I think actually 5 projects have been introduced. 2 of them being planned for the next year, 3 of them already finished. So I have several questions, but before I start, I would encourage you as the audience to maybe raise your hand. Maybe we will even find a microphone to support you. And please raise some questions to the team. I think this is one of a kind of opportunity. You cannot imagine how difficult it was to schedule and find a free slot in their busy schedules. So now you have them here. They cannot escape. Please ask some questions. Do you have anything, maybe? Yes, please, gentlemen here in the 3rd row. Just give us a second for the microphone. Okay.
Hello, Energy Agency of Slovenia. I would like to ask one question to Elis regarding the SINCRO.GRID project. As we know, the project was tackled in 2 phases. I think the first phase is now finished. I'm wondering the second phase or the next SINCRO.GRID. Is it happening, or is the project now in the final stage?
No, the project SINCRO.GRID is divided in 2 phases because it was one PCI project, and it was divided in phase 1 and phase 2. The reason was the construction of substation in Circuce. It was dependent on the power lines between Circuce and Pince. And that was the reason, because we don't have any timeline for this part. that we exclude from the first safe application this part in circuit. So the first SINCRO.GRID phase 1 was completed 100%, and fortunately also the second one. So we complete everything what is connected to the SINCRO.GRID till this August. So everything is finished and everything is in operation. So now we officially send it to the panel reports, and I think we will close this project officially. We have time to November, but I think we will be finished a little earlier.
Thank you very much for your explanations.
Thank you. We have another question. Just pass the microphone. Thank you.
Thank you very much. GABRETA from Hungary. You mentioned in the presentation the battery energy system, 5 megawatt battery energy system. I have 3 questions concerning this BESS. The first one is, for what kind of use cases were used of the battery energy systems? The second one, who is the owner of the battery energy systems? And if the owner of the system operator, for example, of the battery energy system, how do you make it compatible with the regulation?
Okay, the first we implement in 2 places, and the business case was how to put the safety tools in the grid. In that time, actually we lost 10 megawatts for secondary control in our thermal power plant, the boiler, which was closed at the time. So we didn't have any space to control and to maintain the frequency control. This was the first reason in the first step. Yes, of course, the regulatory is changing during the implementation, but now we are still using these devices daily for the support of the frequency control. So we don't have any influence to the market because we cannot have it, but we use this both battery storage for the safety reason, for example, to recovery of frequency changing and so on. So this was the business case. And the second question,
second question, who is the owner? But
Alice is the owner. No, at the moment is the Alice. Yeah.
You also answer.
But we don't use this battery for we cannot influence on the market. This was the point.
Thank you.
Okay, thank you very much. Yes, please just pass the microphone. 1 row. Nope.
Hello, my name is Branislav from EGD, Czech Republic, and I have a question to SINCRO.GRID project. And I saw that one of the implemented technologies that there was extraction from the extraction of the heat from transformers. It seems to me like pretty interesting technology. How does it exactly work?
This is not the SINCRO.GRID project, but this is GREENSWITCH project. This is the new one. But the situation is like this. We use this. Actually, we use the temperature from the oil. You know, the transformer burn is operating, is heating, and we want to. And we do not like to leave this temperature and this energy through the fans. We will keep this temperature during the cooperation of the temperature, and we use the primary circuit is the oil through the cooling system of the transformer, and exchange the temperature to the second part secondary part, and then we will use this secondary circuit for the heating. We already have some pilot project for this one, and we check everything, and there is enough power to heat the building like this one. It's not the problem.
Thank you so much.
Is maybe there a follow-up question? Okay, very great, very good. So my question would be, well, I'm an engineer and I do engineering all day, every day, 24/7. So I would have a bit different questions. Maybe for you, Suza and Tomasz. So how did these projects, basically, because you mentioned how complex they were, how many components, technology they included, how did they shake your company? How did they impact your company? Because what Elis was facing, at least this is what I heard, is a lot of challenges due to procurement processes, a very strict timeline, so a lot of gray hair at the end of the day. Yeah? So and I was wondering, did it impact in any way all those projects and the ideas that you had along the project development? Did they somehow also succeeded in maybe bringing out the positive side of people and the company as an organization? What's your experience on that? Well, ladies first, of course.
Okay. So yes, it did shake up our company. Actually, it's very easy to look and complain and do nothing. So it's very, very easy to do that. And DSOs are used to do that, to be honest. That, oh, we don't have enough tariff, so we cannot invest in smart technologies. What a pity. We write a letter to the regulator and that's all. And I have been working for the regulatory department for a long time. And I was like, why am I writing all these letters one after the other and nothing happens, because actually we cannot increase the prices, the tariffs for the end users. And then I saw the example of Slovakian colleagues, and I thought, okay, we shall do something in order to satisfy our customers, because they are just coming with the increasing needs of renewables and other needs. And so we need to do something, and so this is how I started finding some partners. Fortunately, we found very good partners with Západoslovenska Distribučná and SEPS, that's Slovak DSO, and also the Hungarian TSO. And it did shake up the Hungarian DSO from inside, because we didn't use EU-based public procurement. It's a totally new field for us. Actually, the time is double what we planned for, and we had many difficulties. We also had to adjust all our processes, because we have a specific company who did the procurement for all the DSOs. Now we can use only the DSO, and it needs to procure for itself. We also had to reshape all the financial processes in order to comply with the methodology, which is we need to comply with. So yes, it did shake up, and also the technological. So it was the first time that my technical colleagues, when I started talking about them, okay, so what shall we do? What is the purpose? So the purpose is like satisfying renewables, connecting them to the grid, increasing security and reliability of supply, and doing a smart grid on cross-border level. So also the cooperation between TSO and DSOs on a cross-border level, it was a totally new field for us. And first they didn't understand me. They were like, what is she talking about? And what is this whole thing about? And now I can really dream, and they didn't want to dream. And after a while, I convinced them, and they started dreaming. So we started this project with Peter and other colleagues. And then everyone got really enthusiastic. So it's a very nice journey from being not really proactive to being proactive.
So it's not only the technology that's complex, it's also the administrative or human component, organizational component that's bringing some feelings up front.
Yeah.
Tomasz, was it the same in your case, or would you say it was technology only?
No, it was really the same. We had this kind of conversation with Simon before this event, and we concluded it's like when you have your favorite meal from your mother, and then somebody else is doing it, so it's similar but not the same. And I would say that it's the same thing with this PCIs. For instance, in our case, we are in a situation that all our PCI investments are on top of our regular capital expenditure. So it's also increasing the pressure on the technicians and engineers to prepare the projects. But as Zsuzsa described, really for us, that the biggest learning is, and the biggest change within the organization is that we have to be more on time with project realization, because in a standard environment, regulators are not in the position to push the companies to conclude the investments on time. But in this case, since we are also benefiting from the financial support of the European Union, 50% and 35% in the two projects, so there is obviously also an expectation from the EU to have these projects concluded on time. So I think it's quite a natural relationship in this case, that we are receiving something, but the partner who is giving the money is also expecting these actions to be done on time. But it is having really a positive influence on the whole project, because then the learnings are mirrored and reflected also on the general DSO project. So yes, there is a learning, but there is a positive change.
Which brings me to my next question, Fisnik, for you. I understand that your project is basically starting, right? Yeah. So do you already have some, let's say, indications of such complexities in the path you have taken, or you already have some experience? And the reason for my question is, in many cases, at the end of all the journeys that different people take, they tend to sit down and talk about this, yeah? So not just to say what was good and what was bad, but also to see how to be better in the future. Yeah, so like a forum or a platform to exchange knowledge. So what's your position on that?
As BioNTech, we have zero experience doing projects with the EU or outside Germany. So this is our first project, and we'll hope to learn a lot. We are grateful and happy that we have our partner, EGD, who has more experience in doing PCI projects, and we are learning a lot from them. And today I'm participating here. I think I'm learning a lot also from this discussion that I'm hearing here. And well, I cannot tell a lot, because we have still to do all these things we heard here. So these procurement processes should be aligned with the European Union. Then we should keep our deadlines. Hopefully we will do that. And so these are the points, the main points I'm taking today from our discussions here. But hope to do good experience.
Well, but what I hear from you, or what I take from your words, is that any additional exchange of knowledge, of experience, would be beneficial, not just to you, but basically anyone who started or is starting with PCI projects,
yes,
right?
Sure.
Okay, maybe this is also a message to other people, yeah, to maybe introduce such forums or platforms, because at the end of the day, again, it's not just technology, yeah, it's people who use that technology and do the project. My final question, because I'm already getting an eye here, is I somehow feel that all these projects have many mothers and fathers, right? So it's not only one person doing the project. Yeah. What would be the amount of people, just like, you know, estimation of involved in one of your projects, or for each of the company? Do you have any idea on that? Is it 10, 20, 200? Because you showed us the complexity, you showed us the financial numbers, but I'm not sure that people are getting the actual size of the projects, yeah? So maybe if you have any idea, I'm not sure, please.
In our case, I counted them when we were in the first year, and the implementation was like a half year. So it was like one substation and smaller things. So we just started the procurement process. That time, there were like 115 colleagues working on the project, exactly. And also, apart from those who were, let's say, in the financial or the accounting department. So I didn't count them, just those who worked directly.
So 115.
Yeah, so it has increased since then, but...
What's the total number of employees?
The total number, actually, we have 3 DSOs and the...
or the percentage, what
department.
would be the percentage, for example, is this?
Percentage, okay.
Just
I think in EED it's like 1,100.
So 10%.
So 10%, yes.
So you see, these are not simple projects. It takes 10% of your workforce, at least 10%. Simon, would you support on that, or?
Yes, of course. I think even more. It depends on the phase where is the project. But on average, I can tell that we have near to 200 people involved in this project, beside outside labor force and so on. So it's a lot of people were involved in this project, and we have to take in account that the number of people who will be engaged on such project is quite a lot. I think more than 10% at the end of the day.
Okay, thank you. Tomasz?
I will maybe approach it from a different angle. In our case, I'm in the lucky position that I'm kind of the dirigent of the orchestra, the one visible, but I'm not doing the real work. In case of our company, I'm very lucky that I have 2 very good colleagues who are also here with me, Otto and Stanka, and they are responsible project managers for the two projects. So they are keeping all the lines in their hands. But when it comes to the number of the workflows, I think we have a very limited number of extra FTEs that were employed due to this project. But I do confirm that there's a huge number of colleagues involved in the realization of the project, huge number of vendors, contractors. But as for our case, we have 2 very dedicated project managers who know everything about the project. So when I receive an email from Sainea, from a kind of officer, I'm always contacting my colleagues because they know everything in this project. And I think we have the same structure in all other companies, that we have 1 dedicated project manager and then a lot of cooperating colleagues.
Okay. So, Fisnik, I see the smile is gone. so I guess this is part of the learning curve, right? Yes. So and the message I'm getting is don't underestimate also this portion. Would you have something to say?
I could just tell out how many people are involved in preparation of the project. In our case, it's us. In our case, we are 3 of us who manage this project, but we are using the existing workforce in the Bayernwerk in preparing the stuff, and also we have all external partners who support us in preparation of this project. The execution part is coming, so we have to do still this experience.
Okay, thank you. So my final statement. What I would like to say is, past years or months, we were, let's say, somehow waiting for the baby. Now the baby is here. Yeah, so you know what now starts? Actual problems. Yeah, this is how, as it in real life, the projects do not stop once they are implemented. This is the very beginning of their life. And sometimes we forget about that. Yeah? So take the analogy to a baby, to a grown-up person, how it goes. And our lives are not without challenges, not without problems. So maybe my message to all of you would be, let's also focus on that part of the project life. Yeah? After it's been put out on the planet to start living the life. Thank you very much. This is all from me. Thank you for very nice presentations.